So the first thing we want to take into account are user to movie interactions. So we'll look at each user and each movie in isolation. We won't take into account similarities amongst them right now. We'll just look at each one in isolation and see what we can do about making the prediction a little better. And so the first thing you'll notice, let's just take a look at this this chart over here, and we've highlighted user D and movie 3. And so one thing you notice about user D is that it seems kind of harsh in his reviews, right? Because he gave a 2 when everyone else was giving a 4 or a 5. He gave a 3 to this movie, which everyone else gave a 4 or 5. He gave a 1 where we have 2 other 4s over here, and he gave a 2 where, again, there's a lot of values higher. So D seems kind of harsh, like a harsh reviewer. And then on the other hand, you look at movie 3. Movie 3 seems to get pretty good ratings, except with the exception of the harsh critic D, who gave it a 3, which is still average. He's getting all 4s and 5s, whereas other movies are a bit lower. So you could say movie 3 might be a really good movie, right? So that's the idea here behind biasing, right? Some just tend to have higher mean or average values than others, and that's why we can't just average the entire table. We have to it's better to take the columns into account as well, and the rows and the columns separately. So that's the whole idea again, first of easy or harsh reviewers. You can also imagine that some reviewers, maybe reviewer A over here, might just be much easier than the others, whereas D is much harsher, and he tends to rate much lower. Again, people rate differently, and we pointed out user D for being that one harsh reviewer. At the same time, on the movie side, there's some movies are good, some movies are bad. Some movies are just higher quality, and others are better perceived by the public. So movie 3 seems to be a really, really good movie, whereas 2 might be a little lower quality, or at least perceived less well by the overall general opinion. And again, movie 3 is what we pointed out as well here. This really forms the basis for what we call the baseline predictor. And the baseline predictor, what we do is we take each of these rating values, or we start with the average actually, and we take that raw average. Remember from last time, that was just the 3.5, and then we add in a bias for the user, and we add in a bias for the movie. So the biases are going to be positive if it's better received, or if he tends to be a more lenient critic, and they're going to be negative if it's a movie that tends to be worse, or if the critic tends to be more harsh. And so we have to find the bias for each of these users, and that's the whole idea here, is that we really need to find those bias values. And so finding the bias is somewhat of an art, actually. There is a quote-unquote right way to do it, probably, which would be that we have to solve a complicated optimization problem. Optimization right over here, and but we're not dealing with any calculus or linear algebra in this course, so we won't go that far, and we won't deal with that. We will just look at a simpler approach to doing this. And so we need to find the bias value, so we'll try to do something intuitive. Why don't we just compare it to the mean value, right? So let's just compare it to what the mean was. Again, remember the mean of the overall data set was 3.5, so let's see how much higher or lower the mean is than 3.5, and that's how we find the bias. So we take the average of the row or column. We'll start with the harsh critic D. So we'll take 2 plus 3 plus 1 plus 2. That's the average of these values, 2, 3, 1, and 2. Again, remember, we're not including anything that is in the test set when we do these biases out. Divide that by 4. It's just 4 of those values, and that is 8 divided by 4, which is 2. But then we actually have to subtract out the mean, because we want to do it relative to the overall mean. So we do 2 minus 3.5. So we just can write up here, this is really minus 3.5, this is minus 3.5. So we get 2 minus 3.5, which is negative 1.5. So that's the bias, and that should make sense because D is a harsh critic, so he's well below the average rating of minus 1.5. He's below the average of 3.5. And now let's try the good movie, or movie 3. So we can take the average of the values again. So this is for D. Now we'll try 3. So we add up 4 plus 5 plus 3 plus 5. And again, there's 5 of those. There's 4 of those values. This we don't have, and this is in the test sets. We don't use it. So this comes out to be 17 over 4, which is 4.25. And then remember, we subtract 3.5 from all of these values, minus 3.5, minus 3.5. And this is 4.25 minus 3.5, which gives us positive 0.75. So for D, we have a negative value of negative 1.5, and for 3, we have positive of 0.75, which is significantly above 0, or it's above 0 reasonably enough, which is what we expected, because we expected that 3 was a much better movie than the others. And so the key idea here again, though, is that we can't use the test set. So the test set has to go. And because we're not using that in these prediction schemes, because that's what we're going to test the RMSE on. And so we can do the rest of the values out, and I've given the values at the end of the columns or rows here. So the bias for A is positive 0.83, for B is 0.5, for C is negative 1. Really easy to see. We could do C's, for instance, right now. There's only 2 values. There's a 2 and a 3 here. So we just do 2 plus 3 divided by 2 minus 3.5, which is 5 divided by 2, which is 2.5 minus 3.5, which is negative 1.0. And you can verify the rest of these also. And then on the movie side, again, 2 is a pretty negative movie, actually. 3 plus 2 divided by 3, and then subtract out the mean of 3.5 from that.